The sheer physical footprint of the International Tokamak project at Cadarache establishes the scale of the global fusion mainstream. On its 2024 baseline, this single effort has crossed roughly $32 billion in cumulative investment, with first plasma pushed back to 2034. Robert Bussard's alternative Polywell program presents a different trajectory, having crossed a key confinement threshold in 2005. Across 2 decades of development, the Polywell program received roughly $12 million in direct Navy funding. That creates a ratio of roughly 2,500 to 1. While the international community builds a stadium-sized megaproject, the alternative concept operates in a tabletop laboratory environment. This funding gap reflects the institutional architecture of the United States Fusion Program. The Department of Energy's Office of Science runs the Fusion Energy Sciences Program. The federal fusion budget follows a rigid division. The Tokamak mainline and inertial confinement consume the overwhelming majority of funds. Everything else sits in a scrap pile labeled alternative concepts. Polywell, FRC, and dense plasma focus share this single restricted bracket. Forcing all non-Tokamak designs to compete for the same sliver of funding ensures that no alternative architecture can reach Tokamak comparable maturity. When Robert Bussard took the Polywell proposal to the Department of Energy in the late 1980s, the agency rejected it. Bussard later framed that rejection through his own lens, claiming DOE viewed his work as too cheap and too quick to fit their megaproject model. This decision pushed the research out of the civilian science program and into the DARPA defense research pipeline. ITER's budget continues to grow because Tokamaks scale unfavorably. The plasma pressure needed for fusion rises faster than the magnetic pressure holding it. Maintaining that geometry requires the largest superconducting magnets ever built and a massive cryogenic plant just to keep them operational. Once an institution commits $32 billion to a single device, it's heavily incentivized to ignore cheaper alternatives to protect its sunk costs. The suppression mechanism reinforces itself through institutional structure without any need for secret meetings. The life cycle of a standard fusion career follows a locked pipeline. Graduate programs feed into Tokamak postdocs, who staff the national labs and international collaborations. Any rival concept seeking funding reaches a peer review committee composed of researchers whose careers are built on Tokamak's success. Lukewarm reviews keep the alternative budget small, which means the next generation of researchers never gets trained in those concepts. The peer review architecture functions as a silent embargo, systematically killing alternative ideas because the institution has no incentive to validate a competing architecture. Modern field-reversed configuration research shows the consequence of this institutional exclusion. Private sector companies like TAE Technologies and Helion Energy became the primary homes for these starved concepts. They bypassed the federal government because the DOE's alternative concepts pipeline wasn't a credible path for the scale of investment FRC technology required. Both companies now operate advanced FRC devices that the federal science program refused to fund.